Okay, good morning. Welcome back to statistics. So today we are going to talk about test of hypothesis. Okay, now we'll go into the homework and we'll start that. We have a little bit to talk about as far as error goes before we get into this, but there's a very formulaic way of putting all this together. So I know there's a bunch of parts, but it's not really as bad as it looks. Okay, so let's just go ahead and start here. So what we're going to do, let's talk about what's happening first before we get into the problems. Okay, so we're going to have a test of hypothesis. Okay, now what we're doing is we're testing to see if something is true, right? Somebody's going to say, look, the lead in your drinking water is at a safe level. All right, no, I don't think it is. Okay, but it's going to be up to you to prove that. And the way that you're supposed to prove it, okay, is that we set up a hypothesis. Okay, and we try to make these pretty specific without being overwhelming about it. So the idea that we're going to have a null hypothesis, this is called the null hypothesis. And this is what the status quo is. So when you buy like a 2-liter bottle of soft drink and it says 2 liters on it, you think, I think I'm getting shortchanged. I don't think there's 2 liters in it. So the null hypothesis, the status quo, be there's 2 liters of soda in the bottle you just bought. Okay, you buy some cereal and it's like, okay, it says 16 ounces. I don't think it is. 16 ounces is on the package. That's what you have to go with the status quo. Okay, so whatever the expert makes the claim, that is your null hypothesis. Okay, and then I think your book uses H1. I'm used to using HA for the alternative hypothesis. Okay, so I'll try to use H1 because that's the notation your book uses, but please forgive me when I use HA because that's what I was brought up with. Okay, and it's like which your claim is or what the other person is claiming. Okay, like, I don't think there's 16 ounces of cereal in the box that I bought. I don't think there's 2 liters of soda here. I think there is too much lead in my drinking water. Okay, that's your alternative hypothesis. Okay, and we have a standard of evidence. When they go into a court of law, we say like, must be proven guilty by reasonable, beyond reasonable doubt. So what criteria are you using? Okay, I mean, if you're going to tell me you saw Bigfoot, like I'm going to need more than like a hazy picture. Okay, I'm going to need something like a little bit more substantial. So my criteria of evidence, we're going to say, well, we're going to say that if beyond reasonable doubt, we're going to say, well, that's the probability of getting this result. We're going to say if it's less than 0.05. Okay, but you can choose this. Okay, it depends on what the consequence is of making an error that you're going to use. So usually in academia we use 0.05. Sometimes we use 0.025, 0.01. Okay, or sometimes 0.1%, 10% chance of making an error. This is the standard. Okay, your book actually infuriates me because all the problems they specifically stayed away from this one. Why are you doing that? Mostly because the calculators allow us to use any level they want. You're not on the hook to figure this number out. They will tell you in the problem what your standards are. Okay, and you're going to abide by them. That's what they say. We're going to say P equals, and you're going to say, okay, well, that's you'll know more when we get there. Okay. So step 1 is we're going to state our hypothesis. Okay. Step 2, we're going to note our level of significance. Okay. We're going to note our level, the level of evidence we can have. Step 3, this is going to be the calculator most of the time. Okay, you're going to calculate what they call a test statistic. Okay, and this step is, it used to be a step that was like you'd have to get the calculator out. You'd have to like draw a calculation and do all this. The calculator is actually going to handle most of this for us. Okay. Based on the test statistic, that's going to tell you the probability. Like, was it bigger than 0.05 or less than 0.05? We're going to make our decision. Okay, we're going to make the decision. We're going to say, well, it wasn't 0.05. Okay, it was above that, so we're going to go with this. We're going to go with you did not meet the level of evidence you needed, so we're going to stick with whatever the status quo was. Okay. And then 5, and this is an important step, you must write your conclusion I cannot spell this morning. You must write your conclusion in the context of the problem. In words, someone who has not taken statistics can understand. Okay. So when you write your conclusion, you're going to state what your conclusion is so that a person who hasn't gone and taken this class recently will understand what you're talking about. All right. So that's pretty much the procedure, like 5-step thing to do a test of hypothesis. And we're going to do this in chapter 9.2, 9.3, 9.4, all of chapter 11. Okay, we're going to get a lot of practice. You're going to get really bored of this, which is good because once it's bored, it's easy. Okay, but before we go into all that, before we even go into the math, okay, we're just going to talk a little bit more about like step 1. Okay, we're just going to break this down and concentrate on what's going on here for a little bit. Okay. So test of hypothesis, you can say, okay, HO. Now we have something called a null hypothesis. Okay, whatever you're claiming is true, or whatever the manufacturer claims is true. Okay, this always gets the equal sign. Okay, so you might say something like, I think the average in the soda bottle is 2 liters. Okay, or you could say, I think we either filled it to 2 liters or we overfilled it because we were afraid of this lawsuit happening. Okay, so, or I think there's too much lead in my drinking water. I don't know. I think there is no safe level of lead, but you might say something like, the concentration here is less than or equal to 0.0001. It's less than what we can measure. Okay. So notice that we get the little bar here, we get the little bar here. Okay, we get the little bar here. It always gets the equals part of what's going on. Okay. And then we have our alternative hypothesis. Okay, so this is null hypothesis. And this is the alternative. Okay, so one of the things right off that I can tell you about hypothesis is that it has to be something we can measure. Okay, so if you're concerned about your soda, okay, but nobody complains that you gave me too much. Okay, if you buy something at the store and like, wait, you overfilled this, I'm going to complain. That doesn't happen. Okay, nobody complains about getting too much, right? You think about that, like they put an extra chicken nugget in your chicken order. Nobody's unhappy. Well, the store is, but that's not your problem. Okay, so we're going to say something like, no, I think you underfilled your bottles. Okay, so we're going to say mu is actually less than 2 liters. You're incorrect. Okay, or nobody complains, but I've been given too little lead. I need some for my daily requirements. There is no daily requirement. Okay, the only thing you care about for lead is that it's bigger than what the measurable amount is. Okay, but we could also have, like, maybe we'll put you in the role of the quality control manager, right? Cereal, I don't know if you've gone to the grocery store recently, but cereal's friggin' expensive. And your HA might be, well, it's well, we'll contrast it, sorry. We'll say HO, we'll say we fill them to 16 ounces, and your alternative might be it's not equal to 16 ounces, because for you as the quality control person, for the people making the cereal, if you're overfilling it by too much, like that's not good, because that's product that could have gone into another box. You're losing money. But you also don't want to shortchange anybody. So for you, from the eye of the quality control person, it's bad if there's too much going in there, and it's bad if there's too little going in there. Okay, so these are called one-sided tests. Okay, so these are called one-sided tests because we only care about if it's more than rather, or less than. Okay, in contrast, this is called a two-sided test. Okay, we care about both more than and less than. Okay, if it's more than that, then we have a problem on one side. If it's less than, we have a problem on the other side. Okay, so for you as a consumer, you care about the 2 liters. Actually, even for the quality control person or for the consumer, you might care if it's too much, because if you overfill the things and they break, then that's not good either. Okay, but usually we care if we got shortchanged. Okay, they sold us something that said 2 liters and there wasn't 2 liters in it. Okay, or hey, you know, Mr. Government, you have said there's a safe level of lead in my drinking water. I found that there isn't. Okay, nobody cares. You know, we don't care that there's too little. Okay? So these are both good one-sided tests. We care about if it's more than or less than, or again, if you're looking at it from the point of view from the quality control person, we care if there's too much or too little. So two-sided because less than or greater than is a problem. So that's the kind of thing your hypothesis is going to look at. They're all attached to numbers. They're all something that we can measure. Okay. So the next thing we could do is we could talk about error. Okay, we are going to make mistakes. That the whole point of statistics is saying how often are there going to be mistakes made. Okay, we're not going to say which one it is. We don't know. Okay, but just like confidence intervals, like I don't know if the sample that I picked is too low or too high. I just picked the sample. Now, 95% of the time or 90% of the time, whatever, my interval is going to cover what the true value is. Okay, but I won't, you know, if I take like, you know, 18 different confidence intervals or 18 different samples, I don't know which one failed. Okay, I just know that, well, let's go round up to 20. So 0.05 is 1/20th. I would expect one of those samples to have not covered the mean. Okay, but I can't tell you which one. I can only tell you that I expect one of them has. Okay, so we talk about error, and the way you don't really know what the truth is. I mean, even if you say you're filling the cereal boxes up to 16 ounces, but you don't know. Okay, so we're just going to put this here, like we're going to pretend we actually know reality. Okay, this is the truth of the matter. And then this is your hypothesis finding. This is your test result. Okay, we often make a little analogy for this because I think at this point in time in your lives, like everybody has seen like a courtroom drama. Okay, so you know, at least in the American system, that you're supposed to be presumed innocent. So our HO is not a test of hypothesis because we're not measuring anything. But HO, our null hypothesis that the person who's on trial is supposed to be innocent. We have a lot. I know there's a lot of issues with this. Okay, and H1 is that they're not innocent. Okay, for shorthand reasons, I'm just going to use guilty. Okay, so instead of a test result, we're going to have a jury finding. Okay, now the only person who knows the truth of whether or not you're innocent or guilty is the person who committed the crime. Okay, I mean, eyewitness results are often screwed up. They don't know. So people saw you, like, well, they may have seen you. They may have been confused. They may not have been close enough to see you accurately. So the only person that really knows is the person who's accused of doing it. Okay, so we're going to say, well, they could be innocent. they could be guilty. Okay, but that's the truth of the matter. And then the jury's going to find, right? The jury's going to say, well, they don't say innocent, they just say not guilty. You'll see that kind of language in here as well. Okay, so person goes into the trial, the jury finds innocent, you really are innocent, there has been no error here. Okay, if the person is really guilty, the jury says they're guilty, then there's been no error here. Okay, now you're really innocent, but the jury says no, you're not, send them away. Okay, then what you've done, the null hypothesis is true, but you've rejected it. Okay, you said no, the null hypothesis, we're not taking it. Okay, this is called, in statistics, this is called a type 1 error. Okay, you may have noticed at this point in the semester, we're really good at naming things. Okay, if the truth is you really are guilty, but for whatever reason the prosecutor just didn't, if the prosecutor failed to make a good case for it, the jury said, no, sorry, you didn't do it. Okay, then this is called a type 2 error. Okay, we're pretty good at type 1 errors. Okay, type 2 errors, this is like for a more advanced class. Okay, but type 1 error, this is commonly referred to as alpha. Okay, this is commonly referred to as beta. Okay, so when we set our level of evidence, right, we're going to say alpha equals, and we're going to give a level of evidence. We're going to say 0.02 or something, 0.05. That's your probability of making a type 1 error. That's the probability that you're going to send an innocent person off to jail. Okay. Type 2 error, okay, that's the probability that you set a guilty person free. Okay. So beta is the guilty go free. And type 1 error is the innocent error. Right, that is the innocent go to jail. Right, so there we are. No error is nice, right? But we know we can measure. We can say, look, our chance of committing a type 1 error is 2%. Okay, that's why they say beyond a reasonable doubt. They say, well, we're going to say that we're okay with the fact that 5% of the time we're going to send an innocent person to jail. Okay, like I said, beta requires a little bit more. It needs to be more involved. Okay, so it's not an easy calculation to make, and you have to know some things about the study. Okay, but that's what we're doing with this. Okay. There is a type 3 error. It'll cover it in the book. Okay, but you've been charged with the wrong crime. We've asked the wrong question. Okay. In the Southwest, we have a big problem with arsenic in our groundwater. Okay, so you notice something strange is happening. You say, I think it's lead. Let's test for lead. I'm like, no, it was arsenic. The type 3 error, we tested for the wrong thing. Okay, so you didn't find anything, but it didn't solve the problem. They'll talk about this in the book. It's okay. But yeah, there we go for all of this. Okay. There is a relationship between alpha and beta, but it's not like alpha plus beta equals 1 or anything. That's not true. Okay. But you think about this. If you say, look, I never want to send an innocent person to jail. Okay, I never want to make a type 1 error, and you throw way down on us. We're going to crush this error. Well, what you're doing is you're raising the level of evidence really high, right? So I only want a 0.0001 chance of sending somebody to jail. Like, well, eyewitness testimony is only like 80% accurate. You can't have eyewitness testimony. It's not that accurate. DNA is pretty accurate, but you also have to make sure that the lab you used was proper and that the police aren't corrupt and the lab isn't corrupt or makes mistakes. I mean, you're dealing with human error here, you're dealing with human biases. DNA is pretty accurate, but once it gets into the hands of people, it's still pretty accurate, but maybe not quite as much as you'd hoped. Okay, so you're going to raise the prosecutor's job quite a bit if you clamp down on this type 1 error, because now they can't use the eyewitness. They have to use DNA. You have to hope. You have to do like certifications and everything, and hope that's going to be enough. Okay, so you're going to accidentally let a guilty person go free because you're like, look, I'm sorry, you only had like 30 people see you do it. It's not good enough. We needed something stronger. Okay. Whereas beta, you say, okay, well, I'm not letting anybody out that doesn't deserve to be out. Okay, we don't want this to happen. And there are people that are on juries like, well, if you're in court, you must have done something guilty. That's not good either. So if you say we're going to clamp way down on beta, because God forbid a guilty person would go free, you know, you're going to be like one of those judges who are like, you know, well, they're in front of me, we're hanging them. Okay, or you know, something like that. The police arrested you for something, you must be guilty of something. Okay, and again, that's not really the case. So your alphas tend to go way up. So you clamped you stepped on beta, but now if like you're in the wrong place at the wrong time, the police rounded you up, like, well, that's too bad, you're going to jail. Okay, so you can't like clamp down on one or the other. You need kind of a balance, just like the confidence interval, right? The bigger interval we got, the more confidence we had, the bigger the interval, the less useful that information was, because then eventually it's like, well, all the numbers work. Can't be wrong. Yeah, but that's not helpful. So same thing here. You want to clamp way down on one of them, the other one's going to raise up. Okay, you clamped really hard down on this one, this is going to raise up. You clamp really down hard on, I never want to send an innocent person to jail. I'm like, yeah, but now, you know, like I said, there's 30 eyewitnesses. That's not good enough. So you got to be a balance. Okay, so we have what? We have one-sided tests. This is a number. Okay, well, I'll call it K. Okay, and H1 is mu is greater than K. Okay, you only need the equals. You don't need the less than. You don't have to cover all the bases here. It's implied. Okay, so if you're doing a one-sided test, it's going to look something like this, or mu is greater than or equal to K, and H1 mu is less than K. Okay. Two-sided test, so this is both one-sided, two-sided, HO, mu is equal to K, and then H1 rather, mu is not equal to K. Okay, and again, our alpha, that's the level of significance. Okay, this is what it's called, level of significance. Okay, now this word has morphed a little bit from when they started using it to what we use it for now. And now significance has a connotation that it's important. When this terminology was invented, when we started using this, significant meant it's noticeable. Okay, so you think about like the Princess and the Pea story. The pea was noticeable. Only the princess would think that the pea was noticeable. Okay, but you know, the story is you stack a bunch of mattresses up, and if the princess is a real princess, then she will notice the pea that's on the bottom of like the 20 mattresses they stacked up for her to sleep on. Okay, so it's what they mean by significance is noticeable, not that it's important. Okay, it could be both, but when somebody says statistically significant, they mean statistically noticeable. Okay, don't put this as like it's important. No, just means that you can notice it. It might not be important at all. Okay, so that's what they use by alpha level of significance. This is your chance of committing a type 1 error. Okay, if your chance of type 1 error is really, you know, if it's consequential, you probably want to clamp down on it a bit. Okay, but not too much, because then again, you let type 2 error into the door. So this is in books, it's given to you. Okay, and if you're up to doing this yourself, you will not be alone making this decision, at least not at first. There's usually a committee that talks about like, well, if we make a type 1 error, what's the consequence? Okay. Let's see. Like the drinking red wine for your health. Okay, there's a correlation there, but I don't think there's a causation. We don't have an experiment to do that yet. Okay, or at least not an ethical one. But you know, I'm going to have a glass of wine at dinner. So the truth, the hypothesis is like you have to give it to the benefit of the doubt. Like there's no problem whatsoever. And you're drinking wine every day. You say it's having an effect. Like, what's the consequence of having a type 1 error? Well, assuming it's only one glass of wine, okay, and you're not drinking like the whole like 2 liters or 4 liters of wine every day. The effect of having one glass of wine every day for men and women, your health is not really that affected. Okay, so there's really little consequence to making a type 1 error. So you might say, 0.1. If you have a history of alcoholism, that may not be the same. That might, having a glass of wine, and you may not be able to stick to it. So that would be, my significance is a lot higher because there's consequences for me drinking that wine. Okay, there's still consequences for me drinking it, but one glass as a normal adult, like as a male, that's not a big deal. Women, you get close to the edge with drinking one, okay, every day. But still, I wouldn't say that's a big deal. Okay. So let's see here. So here, determine whether the alternative hypothesis is left-tailed, right-tailed, or two-tailed. Notice that our hypothesis here is a not equals to. That's going to be two-tailed. That's kind of the nice one. Okay, this is going to be two-tailed because they're on both sides. It could be less than, that would be left, or greater than, that would be right. Okay, so we'll go ahead and check. We'll go ahead and write that down. We'll say this side for the alternative, HA is, mu is less than something. That is a left-handed, the left side one. Okay, and if it's greater than, it's greater than K, that's a right side. Okay, so let's go ahead and just, 9.1 is kind of nice, it's not involved to it. Okay, determine the outcome is a type 1 error. By the way, I don't test your, I don't do a quiz on type 1 or type 2 error. Okay, so there's a lot to memorize, I think, because it's hard to remember. We gave them such descriptive names, it's hard to keep them straight. So HO actually is equal to 50. Okay, our test is made. Our null hypothesis is mu equals 50 versus the left-hand side. Mu is less than 50. A true value is 47, but we've rejected the null hypothesis. Okay, they said the truth is 47, but our test said no. It actually is less than. So we should have picked H1, but we didn't. Oh, there's no error. Yeah. HA says it's less than 50. We came up with less than 50. We rejected this one, which means we're picking H1. So yeah, we're good. There's no error here. It's a great decision. Okay. We have a new fertilizer being tested. Let's see, the mean number of pounds of fruit on this plot of land with the old fertilizer was 409. Agricultural scientist says the new fertilizer may decrease. Okay, the new fertilizer may decrease the yield. That's not what fertilizer is supposed to do. State the null hypothesis. Okay, so the null hypothesis is always like this does nothing. Okay, so there's no value. There's no worth about changing. There's no problem with it. We're gonna just proceed and say we're not changing anything. Okay, so when they do a drug test, right, that's the null hypothesis. Like, this is going to lower your blood pressure. Your null hypothesis, it doesn't do a thing. Okay, what your claim is, what you're trying to show is that what your alternative hypothesis is. So they say, oh, it might lower the decrease of the yield. Okay, so we're going to say it's either 409, but this one says it might lower it. So we have to test whether or not it does that. Okay. I will admit to you that some of these, English is not the best language. So some of these are going to be a little hard to interpret. That's normal. Okay. I make mistakes with this too. It's normal. Okay. So restaurant owner claims that the mean output spent by diners is more than $30. Tested made, HO equals $30, but you're saying, no, it's more. They spend more. They reject the null hypothesis. So they said, this is not correct. Okay, HO is not correct. Let's go ahead and just write it down so I can mark it. Okay, so HO, mu is equal to 30. HA, mu is greater than 30. And we say that the null hypothesis is rejected. Okay, so we reject, this is how you're going to say it, reject the null hypothesis. Okay, you should be a little bit formal when you say we reject the null hypothesis, and then you're going to show, the book will do demonstrations of what they want you to type in, but on a quiz, like you're on your own. You don't have to be that formal with your writing. Okay, so remember we said, like, the jury doesn't find somebody innocent. We find them not guilty. Okay, so that's our language here. We've rejected this. What's your plan after that? What's your alternative? Oh, look, it's right there. There's the plan after that. We've rejected this one. We're not accepting it. Okay, we're just saying that, well, that's the only choice we have left. So we've rejected this one. So I guess we're gonna have to go with this. But we're not really accepting it. We're just kind of begrudgingly going along with the alternative because we've rejected this one. Okay. Forgive, I don't think this is sexist, but forgive me if it is. If you are married and you argue with your spouse a lot, well, I don't know how your marriage works, but that's not my business. But sometimes it's not enough. It's too much to ask to be right. Okay, you're never going to be right. But proving the other person wrong is like all you have. And sometimes that's enough. So you don't have to be right yourself. You just have to make sure that they're wrong. Right? So that's how that works. Okay, so we're not accepting it. We're just saying this one is wrong. Okay, not claiming being right, just the other person is wrong. Okay, so we're going to say we've rejected no hypothesis. There is enough evidence to conclude the mean amount spent at diners of this restaurant is more than $30, because that's what we said. We rejected this conclusion. We're taking this one. Okay. If you were to write this, okay, on this thing, you could write something like, restaurant owner is correct. People spend more than $30. Okay, so you don't have to be quite this formal about it, but in the problems, they'll tell you to be formal. They'll force you to be formal. Okay, this is the way you should say it, but I don't want you to get bogged down with the vocabulary either. Okay, so like I said, when you write a conclusion, you write it so that somebody who's never taken statistics can understand it. Okay, so you say, well, there's no evidence to suggest that it's 30 or lower. It's probably higher. Next. Okay, type 1 error. Again, I'm not. This is your assessment for this particular learning outcome to identify type 1 and type 2 error. You're not being quizzed on this. Okay. A company that manufactures steel wires guarantees the mean breaking strength in kilonewtons. That's a unit of force. It's like pounds. Okay, of wires is greater than 50. They measure the strength to be wires of. Here's our test. Mu is 50, or H1 alternative is it's greater than 50. Okay. So this is really what they're trying to prove, right? Is that the breaking strength, like our wires are really tough. You cannot pull them. They're not going to break. Okay, and the manufacturer's spec is it has to be able to stand at 50 newtons. You're selling them at 50 newtons, kilonewtons. So our HO is mu is equal to 50, just 50. if you ever have a chance to like watch somebody actually have to test this, it's really cool. These huge hydraulic things and they just rip apart the wire. Say, okay, and in H1, mu is greater than 50. We are going to get rid of this 500 here because that's not what they asked us for. And notice they don't do this, right? They're not doing that. Or sorry, they're not doing this. They're just saying it's equal to 50, and it's kind of implied that it could be less than. So they're just saying either it's 50 or it's more than 50. Okay, because that's all we really cared about. Okay. If a type 1 error is made, right? If type 1 error is made, what conclusion will be drawn about the mean breaking strength? Okay. So what we're saying, right? Type 1 error is the null hypothesis is true. We've taken HA, but we've accepted, we haven't rejected. Okay. We never really accept anything. Okay, so this is bad vocabulary on my part, but it also helps figure out what's going on. Okay, so we go back up to our little chart, and honestly, if you draw a little chart, that's fine. HO is true, okay, for type 1 error, but we've said the alternative is actually our conclusion. Okay, so we've rejected this one, and we're saying it's more. So the type 1 error is made, then the conclusion strength is it is greater than 50. Okay. And the type 2 error is made. Okay, if type 2 error is made, that means that the null hypothesis is false, right? So type 2, mu equals 50. This one is the true one, but you've made a type 2 error, which means you've taken this one. Okay, I think. Double check. Oops, test hypothesis. Let's go down a little chart. Okay, so the truth is the alternative is true. Okay, the alternative is true, but you've decided that the null hypothesis is actually the true one. Okay, so it really is greater than 50, the tensile strength, but you said no, whatever, maybe your giant ripping machine is not calibrated correctly, but whatever happened, you didn't test it well. So the truth is, right, the truth is it actually is up here, but you've decided that the null hypothesis is true. Okay, so the mean strength is equal to 50. Okay, so the alternative is true, but you've accepted the null. Right. And then this one uses, this test does use a one-tailed alternative. Explain why a one-tailed hypothesis is more appropriate than a two-tailed. If it's a two-tailed test, okay, technically you can't tell me which side it's on. Okay, so if we do HO mu equals 50 and HA mu is not 50, sometimes this is appropriate, right? If you're the quality control person, you want to know, is it the amount we said it was, or isn't it? Because from the quality control person's eye, making it this way, right, that's going to require, well, it can't be too much over, but it can't be too much under. Okay, if you work with cables or anything like that, like nobody's going to complain that my tensile strength, maybe they will, but the tensile strength is too high. Okay, most people, when they're working with cables, are concerned like it's going to break. Okay, so they worry about the tensile strength being too low. So with a one-tailed test, right, we are trying to show that it's bigger than the 50. Okay, so your elevator cables is bigger than 50. Okay, the tensile strength is higher than what they had claimed on the package. As the person buying the cable, that's kind of what you want. Okay, nobody's going to say, oh, You know, I mean, unless you're planning a really elaborate murder or something where you needed the tensile strength to be less than. But you can't tell if it's greater than or less than with this. All you can tell is it's not 50. Okay, with this one, you could tell that it's greater than. Okay, so okay, with a one-tailed test, you can tell that the mean breaking strength is actually bigger than 50. Whereas a two-tailed test, we just won't know if it's the same as. Okay, the mean breaking strength is equal to. Okay, and again, if you're interested in tensile strength, you probably are carrying like, is it at least 50? Because we got to know. Okay, but in a two-tailed test, you won't know if it's more than or less than. Okay. Oh, we will not know if it's not equal to 50. That's all we'll know. Really? Oh, well, boy, I don't like this. Okay, finally. Okay. But again, English is not always the best language for this. Okay. At least maybe my reading comprehension needs some work. All right. Okay. So IQs of a certain, okay, the scores on a certain IQ test are to be a mean of 100. Sample of 32 students are taking a series of coaching classes before they take the test. Let mu equal the population mean score. And what if they'd said like SATs or something? Okay, if every student took the coaching classes, the classes are successful if their IQs show to be bigger than 100. ACTs or some other kind of standardized test. And this one, I don't feel comfortable with this one. Okay, a test is made of a hypothesis. Is it 100 or were the classes successful? There's three possible conclusions, right? The classes were successful, so it mu is equal to greater than 100. The classes are not successful, then they're going to do an average. And the classes might not be successful. Okay. So which conclusion is best if HO is rejected? Okay. So we're going to reject this one. So we're not saying this is right. We're just saying this one is wrong. Okay. HO is wrong. So the best conclusion is they actually might be successful. Because I don't want to say that they are, because I don't want to put stock into this. I just want to say this one is wrong. But I'm not saying this one is right. Okay. So the classes might not be successful. Ugh. I would feel more comfortable saying the classes might be successful. Okay. They don't like it. They're going to say that it is successful. HO is rejected. Okay. They're going to say that. Okay. For all the carefulness that they do with all the words, I like, don't accept it, just reject the other one. Okay. The conditions for the victory conditions for your argument here are not showing that you're right. It's showing that the other person is wrong. Okay. Assuming the classes are not successful, is it possible to make a type 2 error? Okay, let's figure this out. Okay. Truth test. HO is correct. HO is not correct. We'll say H1. Okay. This test found H1 is correct. The test, or HO rather, is correct, and H1 is correct. Okay. So HO is correct. HO is correct. We're good. No error. No error. This was type 1. This is type 2. Okay, so H1 is correct. But our test found for HO. Okay, so that's what's happening here. So what we're saying is these coaching classes worked, but we failed to detect that it worked. Okay. So we've taken HO, or You take an HL, even though the test was correct. So the classes were correct. So yes, it's always okay. A type 2 error is possible. Okay. The classes are not successful when the null hypothesis is true. No. Just going back to look at it. Type 2 error, the null hypothesis was not true, right? We were talking about the alternative, okay, that the test worked. But we failed to detect that the test worked. Right? Fingers crossed. All of them wrong. Okay. The type 2 error is not possible. Type 2 error is always possible. What are you talking about? Class is not successful when the hypothesis is true. I'll take the word for it. Okay, so that is test of hypothesis, that type of error. No math, just a lot of confusing wording, and we're having to work through it. Okay, I don't quiz you on this for obvious reasons. Okay, so that's our intro to test of hypothesis. Again, it will get easier as we do more. So we'll call it there and let this stand.